Next speaker is Sam Skrob-Martin, along with Sherry Sutherland. And the title of the talk, as you can read, but I will read out for you, is Avoiding, Minimizing, or Wrestling, discussing TA's reactions to uncertainty in undergraduate general biology labs. And the floor is yours, Sam.
Thank you, Beth. Like Beth said, I'm a PhD student at Florida State University in Tallahassee, Florida. And I would like to present my work today on TA reactions on uncertainty in undergraduate biology labs. So, before I get started, there's some people that I want to thank. First off, I want to thank the Biotap scholars for supporting me and inspiring this research. The FSU biology department for putting me into my position and granting me access to work with their students. And to the FSU School of Teacher Education and all the individuals within for their support. There have been recent calls for student science learning to involve their engagement in the practices, concepts, and scientific ways of thinking in the service of explaining phenomena. This call has become more relevant as environmental crises and global health concerns have become critical issues in society. All citizens need to be able to use the practices of science to make sense of these issues. Because of this, a primary objective of undergraduate laboratory science courses is to engage students in the practices and thinking of the discipline. Now, in the past, undergraduate science lab courses have not been places for deep thinking, but rather required students to follow prescribed procedures and reproduced already established knowledge. Students did not learn to reason scientifically from these experiences, but got superficial exposure to concepts from lectures, as well as becoming familiar with laboratory techniques, neither of which supported the mission of engaging students in the discipline. But one way to verify that students are engaging in the scientific discipline is through wrestling with uncertainty. Scientific uncertainty is referring to aspects of scientists' work that is non-obvious and contingent, which must be figured out by the scientists and negotiated in response to feedback from peers and the material world. Uncertainty can be presented as non-obvious decisions about what to do and is pushback from both scientists' empirical work and the audience that they're seeking to convince. Scientific uncertainty is endemic to science, and scientific practices are largely concerned with managing uncertainty and drawing conclusions in light of it. Now, there are different types of uncertainty that are present in different scientific investigations and which scientists or students may encounter during their work. For example, they can experience conceptual uncertainty if they have difficulty with an explanation for a trend or difficulty with a conception or idea. They can experience instrumental uncertainty when they have confusion over how a piece of equipment works or how to fix it. They can experience analytical uncertainty when drawing meaning from often ambiguous data through analytical procedures. They can experience measurement uncertainty when making measurements of phenomena. And finally, scientists and students can experience signal uncertainty when there's ambiguity in the trend of data, and that ambiguity lives in differentiating if the trend is noise or is an actual pattern. For undergraduate biology courses to be aligned with the vision of the AAAS and other reform efforts, students will need to wrestle with and make sense of scientific phenomena. And students may face these different types of uncertainty as they do that. One aspect of students developing proficiency in science is becoming familiar with the culture of science, including scientific discourse. Therefore, students participating in science talk in classrooms is pivotal for understanding the scientific discipline. In undergraduate biology labs, the teaching assistant, or TA, fills the teaching role in the classroom, and different interactions between the TA and student can lead to different learning outcomes. The types of questions that a TA asks can change the type of thinking that students engage in. For example, some questions that the TAs ask can prompt them to give factual information, while other questions can open up the opportunity for students to participate in scientific discourse. These interactions between TA and student, we hypothesize, are important for how students wrestle with uncertainty in classrooms. So the research question we sought to answer in this study was, how do undergraduate teaching assistants support undergraduate students as they navigate uncertainty during investigations in a non-majors lab? So in this study, 4 of 16 TAs were involved, but for the sake of time, I'm going to focus on 2, Charlie and Tom. Both Charlie and Tom were first-year TAs, undergraduates with senior class standing. Tom was a biological science major, and Charlie was a biological science and education double major. This study took place in a general biology lab course that was designed for non-science majors at Florida State University, and it served to fulfill non-STEM majors' science lab requirements. Because of the COVID-19 pandemic, the lab was transitioned to online, where labs were hosted synchronously through Zoom. Students and their TAs met on the online Zoom meeting, had discussions around guiding questions, and collaborated together in breakout rooms to make claims that answered those guiding questions. So to understand the interactions between TAs and students during times where students were experiencing uncertainty, we transcribed the small group interactions at the utterance level using Jeffersonian notation to note the affective valence of the participants. The interactions where students were specifically wrestling with uncertainty were separated and coded for the following objects. First, the object of the uncertainty, or what the students were wrestling with, to the type of uncertainty the students were wrestling with, the TA and student moves during the discussion, and the TA and student reactions to that uncertainty. In this study, we noticed 2 main patterns for how students and TAs interacted with the uncertainty that was present in the lab curriculum. We observed that the TAs handled uncertainty differently, as well as had different reactions to that uncertainty. When we evaluated the 2 TAs' reactions to uncertainty, their reactions focused on 3 main types. They either avoided the uncertainty, which occurs when the focus shifts from conceptual to procedural processes. There was a mixed administration and wrestling focus, which occurs when the focus shifts from procedural questions to wrestling with uncertainty, or continuously straight wrestling with uncertainty. Our 2 TAs, Tom and Charlie, reacted similarly to many instances of uncertainty, but there were 2 notable interactions that set them apart from each other. In both interactions, the affective valence, or the feeling that the students were giving off, were negative, largely perpetuated by student frustration around the task. But how the TAs reacted to this negativity and this uncertainty was different. The first interaction that we're going to focus on is a group of Tom students wrestling with lab 4. The guiding question that students had to answer in this lab was, what is the effect of polluted water runoff on sea urchin fertilization success? In this lab, students examined images of sea urchin eggs that have been mixed with sea urchin sperm and exposed to a specific pollutant to investigate the effects of water pollutants on the process of fertilization. Students had to determine what they would quantify as successful fertilization, how they would collect the data from their eggs, and make interpretations from the data they collected about fertilization success. In this interaction, students were in the beginning of the activity, And Tom, the TA, came into the students' breakout room to monitor their progress on operationalizing fertilization for their group. Students had just begun the activity a few minutes prior, and some confusion was present. Tom asked the group what specifically they were looking for that would indicate fertilization. Therefore, Tom asked a question that focused on measurement uncertainty. Kathy, one of the students, had a conceptual question about what fertilization or mitosis might look like in the eggs, pointing out that some of the eggs may be split or have a ring around them. She asked what those rings or halos meant for their group. Tom focused on the procedural aspect of the conceptual question, turning the attention towards the procedure of operationalizing instead of supporting students wrestling with conceptual uncertainty, relating mitosis as evidence of fertilization. Tom directed the thinking towards what operationalized definition he thought would be easiest for them to collect for their data. But Kathy still pursued the conceptual questions, asking if there's a difference between cells that have divided once or twice. But Tom still drove the focus to the procedure of writing the operationalized definition. So this is an example of how a TA can shift the attention from wrestling with conceptual ideas to focusing on procedure. And the second notable interaction, we're going to focus on a group of Charlie students wrestling with uncertainty in lab 6. The guiding question that students had to answer in this lab was, did two identical twin sisters inherit a mutation in the BRCA1 gene? In this lab, students examined data from a gel electrophoresis in a DNA microarray to determine if a pair of twin sisters inherited the BRCA1 gene mutation from their mom. Students had to use their understanding of genotype and phenotype to come to their conclusion and make sense of conflicting results from the gel and the DNA microarray. In this interaction, students had been analyzing the data for several minutes and were starting to become frustrated before the TA Charlie entered the breakout room. First, Charlie asked the students that if they had any questions about reading the gel electrophoresis. By asking this question, Charlie is addressing a potential moment of analytical uncertainty. Camille, a student, explained that she was having difficulty understanding what the dots meant. The dots indicating specific alleles on the gel electrophoresis. Charlie pressed the group to interpret what the gel was telling them, asking if the markers told them that the twin sisters inherited the BRCA mutation. Camille explained that she understood the interpretation of the gel, saying that the mom had a blue dot and the sisters did not, but wrestles with the conflicting results of the DNA microarray, which Charlie clarifies. Camille explains her thinking about the DNA microarray and gel electrophoresis results, saying that she thinks both sisters inherited the mutation, but only one sister expressed it. Charlie continued to press Camille to support her interpretation of the results by focusing her attention first to the gel electrophoresis and calling forth previous knowledge about alleles and what a gel can indicate about alleles. So this is an example of how a TA can maintain wrestling with uncertainty, and in this instance, analytical uncertainty, through their questioning and interactions with students. So in conclusion, TA student interactions can contribute a lot to the learning that students do in the classroom. If a TA avoids the uncertainty and breaks things down to procedure, then it eliminates opportunities for wrestling that students get. As a result of this, students need to understand that wrestling with uncertainty is what supports students developing proficiency in science, and that they need to be uncomfortable with it and embrace this kind of complex thinking. An implication of this is that student TAs may need training or resources in how to embrace and support students wrestling with uncertainty. That is my presentation. Thank you for viewing it, and I very much look forward to answering your questions.
Thanks so much for that talk, Sam. Let me go ahead and ask a question from our chat coming from Beth Schuler. Did your design include interviewing the TAs? I can imagine that sometimes the TAs were uncertain about what the students were uncertain about. And I know that happens to me sometimes. So can you comment a little bit more on that?
Yeah, this specific design, this specific investigation did not include TA interviews. I did interview some of the students during the after the fact to see specifically about these moments, to see what they were confused about or what they were wrestling with. And it was about these ideas. But I did not interview the TA specifically to see what, if they understood the students' uncertainties. But that is a good methodological idea.
Yeah, thanks. For everybody else in the audience, feel free to put in your questions in the chat. And, oh, okay, there's a follow-up question. Let me go ahead and just read that question. So did students think the TAs understood what they were asking or just avoiding answering their questions?
So I believe that the students understood what the TAs were asking and in pushing their thinking, but they were uncomfortable with it. In lab 4 and lab 6, it's a 12 lab course. So at this point, these students did have experience with the TAs pushing their thinking and asking these more conceptual questions. But these were lab 4 and lab 6 are 2 of the more complicated labs. And so I think the students did think that the TAs understood what they were asking, but were kind of overwhelmed and frustrated with the interpretation of the results.
Thanks for sharing more about the context. We have another question from Josh Wilshalu, and her question is, did the TAs have any training to support student wrestling with uncertainty? And I'm gonna tap on a question of my own. It's like, based on your study, do you have recommendations on how to provide that training?
Yes, so I have, so I trained these TAs in their professional development. I taught them how to teach these labs and the different pedagogical moves they can use. So I did explain to them that students may be uncomfortable with this uncertainty and that they may push back and not want to work through it. But by giving them I gave the TAs talk moves and kind of emotional supports to try to tell them, like, it's okay, they may be uncomfortable, but this is just something that will happen, and that's okay. That is kind of how I tried to help support them in navigating, number one, the uncertainty of being in a lab course on Zoom, and then like supporting student science learning. And then I do have the chat looking at how undergraduate TAs are often tempted to placate students as fast as possible with the answers. And I do agree, a lot of our TAs were not comfortable with the frustration, and we're not comfortable with the students themselves being frustrated. So they like to kind of calm them down and wanted to, like you said, placate them and have them be relaxed. But I tried to get our students and our TAs comfortable with the fact that it's okay to be uncomfortable in science, and we'll get to a place where we're comfortable with that.
I have a follow-up for that. It's a request coming from Dan Johnson as well as Jackie Shea, and they're interested in, would you be willing to share those talk move strategies? It sounds like there's a lot, so it sounds like maybe like a conversation for later. If there's a way that we could share some of the resources that you've developed, maybe you could brainstorm that, and then maybe people could put in their contact information privately to Sam. Maybe that's a good way to mediate that, since you already shared a little bit in person. or through this conference. Hey, thanks so much for sharing more. It seems like there's one more question, but you could continue conversation afterwards. So thank you so much.
Thank you.